Okay, Ji. So in today's class, we're gonna discuss some more questions related to the voltage drop, and then we move to the resistance and how the resistance and the resistance current and the current voltage graphs are plotted. Inshallah, I will try to complete that thing as well. So right now you can see here, the question says Arun has a series circuit with a 6-volt battery, two identical buzzers, and two identical lamps. So since the connection that is given in the question, it is series, right? So two identical buzzers and two identical lamps, they are connected in series, right? With a battery of 6 volt. That means EMF is 6 volt, right? The voltage across one buzzer is 1 volt. Okay, calculate voltage across one lamp. So let's draw the circuit and then we can do it. A battery of 6 volt, right? This is the battery. And we have 6 volt over here. And buzzers are connected. Two buzzers are connected, right? It does not matter what order you follow it in making the circuit, right? Either you can place the lamp first and then buzzer and then lamp. Okay, anyway, but the connections have to be in series. ठीक है जी, ये हो गया। अब हम क्या देख रहे हैं कि दे आर सेइंग voltage across one buzzer. That means if I connect a voltmeter over here, because in order to measure the voltage we have to have the voltmeter connected in parallel, right? You always have to connect the voltmeter in parallel. Okay, and how to connect the parallel, how to make a parallel connection. You can see here the wires, they should be come out, okay, and then they will be connected with the voltmeter. We won't consider the current enters the voltmeter, okay. After connecting the voltmeter, we won't consider the current is going to flow with the voltmeter as well. The current has still one path, right? In the parallel circuit, the current has multiple paths, right? Now over here, what we are observing, the current starts flowing from here, which is a conventional current. And if we take a current from the negative terminal, so it's a electronic current. So we call it capital I. Capital I is the current that flows. Now what we know is the reading across one buzzer is 1 volt. So ultimately, if I connect another voltmeter here, so I will have 1 volt across it. Why? Because since it is the information that is given in the question that one buzzer is having one voltage or voltage drop across the buzzer is 1 volt. So another buzzer, which is an identical buzzer, therefore it has to have the 1 volt, okay, across it. Now we have EMF, which is the total voltages, 6 volt. That out of 6, the 2 volts are dropped across the two identical lamps. So we have now 4 volts to drop to two identical lamps, right? Now we have total 4 volts that will be dropped between these two identical lamps, right? So what we are going to place here, if I place another voltmeter here, so each voltmeter will give me, let me call V1, V2, V3 so that we can identify, okay? Now V1, sorry, V3 will show, since we have 4 volts, right? So the 4 volts will be divided across these two identical lamps. Each lamp is going to have 2 volt, okay? I hope this point is clear. So far we have done the part A. Part A is about getting the value of the voltage across one lamp, voltage drop or potential difference as well. Yes, remember this thing, voltage drop and the potential difference are the same things. Okay, so that's going to be, that's A part now, right? So A is in the part A, they are asking about voltage of one lamp. Okay, so V3 is going to be 2 volt and V4 is going to be 2 volt. Right, now let's move to the part B. Arun adds another 6-volt battery in series. Now they are saying the battery is connected in series. So let's make another circuit. So each battery is of 6 volt. So the total voltages will be 12 volt now, okay? Because 6 volt and 6 volt will become 12 volt. In series, whenever we connect a battery, the total voltages increase. That means EMF is going to be 12 volt, okay? With the first battery, all the components continue to work properly. Now they are saying state the voltage across one of the buzzers when the second battery is added. Okay, the circuit we have, yes, so we have this same circuit, but the only difference is that we have added additional battery here. Okay, now since when we had 6 volt, so the voltage across one buzzer was 1 volt. Okay, now when we have double the voltage, right, so the each voltage drop will also be doubled. Okay, so that means if I connect a voltmeter here, the V1 is going to show 2 volts. If I connect a voltmeter here across the second buzzer, so the V2 is going to show 2 volt. Okay, since they are identical, it is already written in the question. Now when we talk about the lamp, so here it's going to be V3. So V3 is going to be right, so 12 minus 4. How this 4 comes? Because across both the buzzers, the 2 and 2 voltages are dropped, so altogether they make 4 volt, right? So we have subtracted the voltage drop across the two buzzers, that is the 4 volts, right? Now the remaining voltage will be 8 volts, right? Now these 8 volts are going to be divided, right? So V3 and these 8 voltage will be dropped equally because both lamps are identical, right? It is given in the question, right? Now V3 is going to be, if you divide 8 into 2, you will get 4, right? So 4 volt across each lamp. So that's going to be 4 volt. So the state the voltage across one of the buzzers when the second battery is added. So we have found out all the values, right? Okay, they only ask us to find out the voltage across one of the buzzers, but we have found out all. Okay, now state the second question says that the part B was the part B, right? Part B, part 1. Now we're gonna talk about the part 2. State the effect on the current in the circuit of adding the second battery. So the current increases, right? Current increases because we know that when the voltage increases, the current increases, right? So the current is directly proportional to voltage. That means when you increase the voltage, the current also increases, right? What happens to the buzzer? Sorry, what happens to the brightness of each lamp? The brightness would also increase, okay? This is not the question given here, but I am just adding it. The brightness of each lamp increases. The brightness of each lamp increases. So I hope this point is clear. Now we're going to talk about the resistance. Okay. What is resistance? G. So resistance is actually a measure of how easy or difficult it is for the electrons to move through a material, right? ठीक है. For example, conductors के पास जो resistance होती है वो बहुत low होती है as compared to the resistance of insulators, right? So resistance is actually a property of the material to oppose the flow of the charge. ठीक है. The ability of a material to oppose or resist the flow of charge, right? Flow of charge, you call it electron, right? Or the flow of electrons. So what we know that conductors usually have low resistance than insulators, okay? ठीक है जी. अच्छा, अब रेजिस्टेंस को हम जो यूनिट से मेजर करते हैं, जिस यूनिट में रिप्रेजेंट करते हैं, दैट unit is the unit of resistance, the unit of resistance is ohm, right? And the symbol is this, right? We can write the resistance like 1 kilo ohm. This means 1 into 10 to the power 3 ohms. We can also write 500 mega ohms. Okay, so this means 500 times 10 to the power 6 ohms. Clear? We can also write in this form 0.7 876 um, mega ohms, right? So you can write in this way 76 into 10 to the power 6, or you can shift this and move this 10 to the power and shift the decimal to the right hand side. So that's going to be 1, 2, 3, 4, 5, and 6, right? Okay, so either of the ways you can use, right? And now resistance, how will you calculate the resistance basically? So the very basic concept is you divide the voltage drop by the current. So symbolically we can write R equals to V over I. मिक्स है, मिक्स नहीं है ये तो. अच्छा. कुछ कंडक्टर्स होते हैं, दे आर डिजाइंड दे आर डिजाइंड टू हैव अ हाई रेजिस्टेंस, राइट? तो जिनमें से आपके कुछ लैंप्स होते हैं, उनमें एक वायर होती है विच इज नोन एज अ फिलामेंट. और फिलामेंट की जो रेजिस्टेंस होती है दैट इज हाई, ओके। तो व्हेन द करंट फ्लोज थ्रू द फिलामेंट व्हाट हैपेंस, वह आपकी एनर्जी, थर्मल एनर्जी, क्योंकि वो हीट अप हो जाता है, व्हेन इट गेट्स हीटेड अप, सो इट ट्रांसफर्स द थर्मल एनर्जी टू द सराउंडिंग्स, राइट। तो आपकी डिसिपेट एनर्जी जो वो ज्यादा हो जाती है। तो एक बात और याद रखिएगा कि सिंस वी हैव डिस्कस्ड द if if the resistance, not we have not discussed, but yes, the material, sorry, the resistance actually slows down the flow of charges, right? क्योंकि वो अपोज कर रहे हैं तो स्लो कर देंगे। तो if the resistance is greater, if the resistance is greater, the current will be lesser, okay. So this means current and resistance have current and resistance have uh, inverse relation, right? If you increase the resistance, the current is going to increase, right? Assalamu alaikum, Mustafa. Are you there? Yeah, Mustafa Ghani. Yeah, Mustafa, can you please join the class? I'll communicate the timings, right? Okay. Hello, Mustafa. Are you there? Mustafa Ghani?
Yes, welcome, Sam.
Yeah. I'll communicate the timings, right, for your class. Okay.
Okay. Do I leave the meeting?
No, no, you have to leave. Okay. And then when I text you, then you can join. Okay.
Okay.
All right. All right, so we were discussing about the current and the resistance relationship, right? So if you increase the resistance, the current decreases, right? For example, let's have a one circuit where we have one cell, okay, and our resistance is connected, right? And a lamp is there. Now, and another circuit where we do not have the resistance but we have the lamp, okay, directly connected to the cell. So the difference between them, we will observe that the current flows through this socket, this one, the current that is flowing through this one, and the current that is flowing through this circuit, okay, the current would be different, okay, number one. Number two, the brightness of the lamp would also be different, okay. So here in this circuit, in this socket, the flow of current is greater, okay, and the brightness of the lamp will be greater, you can say, or whatever the word you can use. Now, by connecting the resistance, when the resistance is connected, so the current decreases, the total current decreases, the lamp, the brightness of the lamp would also decrease, okay? Brightness of the lamp also decreases, right? So this is the effect that happens, you know, in the circuit when you connect the resistance. All right. Now, uh, in this question, they are saying the diagrams in this question show parts of circuit. Parts of circuit means that the only cell is not connected, but we have to assume, yes, the cell has to be there, right? Okay. So if they are not showing the cell is not connected, so it does not make any difference in our calculation, right? Why? Because we have to assume that the cell is there. Okay, whatever the value of the cell is, we are not going to take care, but we have to assume the cell, the energy source has to be there so that the current flows through it. Now, what we are observing in the first part A, the first part says that the circuit contains 6 ohm resistor. The current through the resistor is 2 ampere, right? As I told you that when the the voltmeter is connected, so you will not assume, you will not say the current enters in the voltmeter. The current does not enter in the voltmeter. Why? What is the reason? So you will study in grade 11 as well. Okay, so you do not have to consider that the current is entering the voltmeter. Still, the current has only one path. Clear? Yes, if I have other component than the voltmeter in the same circuit, let's say I have this circuit which is having a ammeter connected, having 2 ampere current flows through it, and here the lamp is connected across the resistor, and here is the resistor of 6 ohm. Then we can say the current is going to split up across the lamp and across the resistor as well. Okay, clear now? All right. Now in this question, the diagram contains 6 ohm resistor. The current through the resistor is 2 ampere. Calculate voltage across this resistor. Now what we know, first of all, you have to make the data. The current is known to us, which is 2 ampere, and the voltage across the resistance is unknown. We have to find out, and the resistor value is 6 ohm, right? Okay. Now, since from Ohm's law, what we know mathematically, V equals to IR, where V is unknown, so we can substitute the values and you will get the answer. Okay. So 2 times resistance, that means 12 volts. Okay, right? Now here we go with the part B. This circuit contains 100 ohm resistor. The voltage across the resistor is 12 volt. Okay, and calculate the current, right? So what amount of current is flowing through this circuit, right? And it is flowing through the resistor. What is the amount of the current, right? What reading does the ammeter show? Clear? Mm, okay. So this time we do not know the current. Okay. We have the voltage across the resistor, which is 12 volts. Okay. And this time the resistor which is connected is 100 ohm. Now we're gonna do the same way. We're gonna follow the same way. V is equals to IR. Okay. I equals to V over R, where V is 12 volt and R is 100. So we're gonna get 0.12 ampere, right? Now, if I ask you to find out the power, so inshallah in the next class, I'll take up the explanation of power. But right now, you just need to uh, keep this concept in your mind that value of resistance depends on few factors. Depends on the length of the wire. Okay, greater the length, greater the resistance would be. Okay. So resistance is directly proportional to the length of wire. Okay. Second thing is resistance is inversely proportional, inversely proportional to the cross section of the wire, cross section area of the wire. Okay. That means thicker the wire, lesser the resistance would be. Okay. Okay. Thicker the wire, lesser the resistance would be. Lesser the resistance. Right? And the next, the last is resistance is also depends on the temperature. Higher the temperature, higher the resistance will be. Okay. Because the vibration of the atoms increases and the electrons, the movement of the electrons becomes slow down from one atom to another atom. Right? And the next thing you have to remember while doing the calculation that if I ask you to, I have the current, let's say 2 ampere, okay, and the total voltage of the cell is 6 volt, and the two resistors are connected. This box is actually represented the resistance, right? So R1 and R2. R1, let's say it is 10 ohm, and let's say R2 is 20 ohm. So on which resistor the voltage will be dropped greater? So you have to find out the, for example, if I say I connect a voltmeter across R1, so what will be the value of V1 and what will be the value of V2? That means you have to find out the resistance, right? Sorry. You have to find out the voltage drop across 10 ohm and 20 ohm, okay? So we know the resistance is 10 ohm. We know the total current, which is going to be 2 ampere, right? We know the total current that is flowing through each resistor. We just need to find out the V1. So V1 equals to I R1. Why I'm not putting I1? Because we know that the current flowing through R1 is also the 2 ampere and the current flowing through R2 is also 2 ampere. So there's no need to put I1. Okay. Now I is 2 and R1 is 10. So you got 2 times 10. That's going to be 20. Oh my God, what a calculation that I have done here. I have to make the changes in the supplied voltage. Okay, let's make the question like this. What will be the total voltage or what will be the voltage of the cell? Let's make it in this way. Now I want to uh, find out the voltage across V2. So the resistance is 20 ohm. Current is going to be 2 ampere. I have to work for the V2. So V2 is going to be I R2. Since I remains same in the series circuit, remain same in the series circuit does not mean that it cannot change. It can change when you increase or decrease the resistance or any load. Okay. The total current, whatever the total current, is there, uh, will have to flow equally through each component in a series circuit. Clear? Now I is 2 ampere and resistance is 20. So you got 40 volt over here, right? Now, what is the total voltage? So EMF, or what is the battery voltages? EMF is going to be V1 plus V2 since it is a series circuit. So in series circuit, the voltage are divided, or in order to find out the total voltage, you can add all the voltage drops, right? So here we go, 20 plus 40, we're gonna have 60 volt cell. So ideally 60 volt cell we do not, we do not have, but for this calculation we can, consume 60 volt. Okay, right? So I hope that you guys, oh, okay. One thing I want to discuss, if you can observe the voltage drop across both of the resistors, so you will see the voltage drop is greater across 20 ohm. Yes, the voltage drop across 20 ohm is greater than the voltage drop across 10 ohm. So remember this concept as well. V2, if you can compare the voltages or across 20 ohm and 10 ohm. So V2 is greater than V1. Why? Because R2 is greater than R1, right? And this is only for the series circuit. This means if the resistance is greater, the voltage drop across that resistor will also be greater. Okay, right? I hope this concept is clear.